Hello students! In our previous video, we constructed two tangents from a given point outside a circle. Recall that we were given the center of this circle and the distance at which the point is located from the center of the circle and from where we wanted to draw these tangents to the given circle. Now in this video, let us see a situation where we are given a circle, its center, its radius and a point P. But students, we are not given where point P is located. That is, at what distance it is from the circle. In fact, we are given a condition that construct the tangents from P to the circle such that they make an angle of 60 degrees with each other. But before we see the steps of this construction, note that angle made by two tangents with each other is always unique as per its distance. This also means that by changing distance, the angle between them will also change. Say for example, if at point P, they make 60-degree angle. If we shift P towards the circle, the angle will increase. Or if we shift P away from the circle, the angle will decrease. So students, let us draw a pair of tangents to a circle of radius 5 cm, which are inclined to each other at an angle of 60 degrees. As I told you, here we are given a circle of radius 5 cm and a point P from where we want to draw these two tangents. But the distance of P is not given. In fact, we are given that angle between these two tangents is 60 degrees. The tangents then can be constructed in a following manner. Draw a circle of radius 5 cm and with center as O. Take any point Q on the circumference of the circle and join radius OQ. Now draw a perpendicular to OQ at point Q such that angle Q is 90. How will you draw this perpendicular? For this, take a compass with a suitable radius and Q as a center, make an angle of 60 degrees. From this arc, draw another arc making another 60-degree angle. Thus, the whole angle is now of 120 degrees. Now construct the angle bisector of this angle as shown. This will give us 30-degree angle. Now draw a line at Q passing through this point F that we have got by drawing an angle bisector. Now we can observe that angle OQF is equal to 90 degrees. And we can say that OQ being radius, line QF is the tangent to the circle. Now can you answer me why? Yes, you are right. Because tangent is always perpendicular to the radius at the point of contact. So we got our one tangent. Now we want to construct the second tangent. For that, draw another radius OR by taking R on the circumference such that OR makes an angle of 120 degrees with OQ. Now students, to make 120-degree angle, take a compass with suitable radius. Draw an arc taking O as the center and such that it cuts OQ at M with the same radius and M as the center. Make another arc on the previous arc and call it as point M dash. Again, take M dash as center and with the same radius, draw another arc, say at point N. Join OR through N. We find that angle OQR is the required 120-degree angle. Now draw a perpendicular line to OR at the point R, just as we did for point Q. Again, considering OR as the radius, line RS is the second tangent to the circle, since radius and tangent are perpendicular to each other. Now observe that both the lines QF and RS, that is, both the tangents, intersect at point P. Therefore, PQ and PR are the required tangents at point P, making an angle of 60 degrees with each other. To verify it, we can check that angle with the help of protractor, and we observe that it is 60 degrees. Now the question is, why did we choose angle between two radii as 120 for the construction? It is because we wanted tangents that made 60-degree angle with each other. Confused? Let us understand it. On observing the figure, we find that two tangents and two radii make a quadrilateral. We also know that we constructed tangents PQ and PR, and so they will make 90-degree angle with the respective radii. Therefore, angle OQP is 90 and angle ORP is 90 and angle QOR is 120 degree. That's what we have drawn. We know that the sum of all interior angles of a quadrilateral equals 360 degrees. Therefore, for quadrilateral PQOR, we can say angle OQP plus angle QOR plus angle ORP plus angle QPR is equal to 360 degrees. Therefore, if we substitute the values of individual angles,
therefore, angle QPR is equal to 60 degrees. So I hope now you know that since we wanted tangents making angles 60 degrees with each other, we made 120 degree angle between two radii. So what if we want tangents at an angle of 80 degrees? In the same calculation, let us substitute angle QPR as 80. And we find that angle between radii, that is angle QOR, must be 100 degrees. Thus, while doing construction for this particular angle, make angle of 100 degrees between these two radii, so that we get angle between two tangents as 80 degrees.
We saw a case where we were not given the distance of a point from the circle. If we take a condition where we are not given center of the circle, can we still draw tangents to this circle? You must be thinking, how is this possible even? How can we draw a circle without a center? It's simple. Take a bangle and draw a circle. Here, we will not have its center. So if I ask you to draw tangents from an external point to this circle, can you? Let us see in such a condition how can we draw tangents to this given circle. In such a case, first find out the center of the circle, and we can find out center of the circle by drawing two non-parallel chords, say AB and CD, in a circle. Draw perpendicular bisector for both AB and CD. Point O, at which these bisectors intersect, will be the center of this circle. This is because the radius is always a perpendicular bisector to any cone, and two radii will always intersect at the center of the circle. Therefore, here point O, where two radii are intersecting, will be our required center. draw tangents to this circle from point P. Outside it, say at a distance of 8 cm from its center O. Follow the same procedure. Let's quickly revise it. Join PO and draw a perpendicular bisector to it. Let M be the point where bisector intersects PO. Therefore, M is the midpoint of PO. Taking M as the center and MO as the radius, draw another circle. Let this circle intersect the previous circle at points Q and R. Joint these points Q and R to the P. Thus, PQ and PR are the required tangents from an external point P. Now students, try this construction by yourself as a self-exercise. Draw two concentric circles of radii 3 cm and 5 cm. Construct a tangent to the smaller circle from a point on a larger circle, and also measure their lengths. Students, here we have to draw two concentric circles of the given radii, and also we have to construct a tangent to the smaller circle from the outer circle. Steps for this construction are as shown on your screen.